everyone. I'm Kelsey.
And I'm John.
And we will be representing Team Scope. Our presentation will be in two parts, Old Scope and New Scope. So let's begin. Old Scope stands for Screen Compensation for Optical Enhancement. So here's the problem. With the increasing use of computers in our daily lives, we're spending hours in front of a screen, which leads to eye strain called computer vision syndrome. Team Scope is specifically looking at accommodative spasm. Accommodative spasm is when the ciliary muscle in your eye is in a state of a contraction for too long, which leads to eye strain symptoms such as decreased blink rate, eye redness, and eye discomfort. So this leads to why we're choosing 3D technology. When you watch a 3D movie, you see the screen either pop out at you or there's the perceived depth. Team Scope wants to take advantage of this perceived depth, which leads to our research question. How can 3D technology be implemented in order to create a more dynamic screen for users and reduce or eliminate accommodative spasm? To elaborate, we want to manipulate the focal distance and the frequency of oscillation of this perceived depth. This will create a more dynamic screen for the users, and hopefully the user will be less prone to accommodative spasm symptoms. So how will we do this? Well, our experiment will be in 3 to 4 testing groups. There will be 1 control group and 2 to 3 groups with varying parameters where we will be manipulating focal distance or the frequency of oscillation. The experiment will also be double-blind, which means that the administrator and the participant both do not know what group they are in. It will consist of a 45-minute reading activity, where they will be reading passages and answering questions about the passage. And then we will be given an eye acuity test and a survey before and after so that we can see the difference in between the symptoms. We'll be measuring the eye redness and the blink rate using MATLAB, and the survey we'll be using for any eye discomfort symptoms. So here's an example of our setup. The stacked books and the cup are for a chin rest so that we can keep consistent the distance between you and the screen, and as well as the distance from the height from the table to your chin. We have the light source there because eye strain symptoms can also come about when there's not enough light in the room, so we don't want to take that factor into account. And not shown in this figure is that video camera that will be behind this screen so that we can take the video for the blink rate as well as the eye redness. So here's how we broke down into teams. We have coders who are developing our prototype. We have an IRB team because we are doing human testing, so we need to get approval. We also have a grant team because we want to compensate our participants. And lastly, we have a literature review and methodology team, so we can constantly update those documents as well. So for the sake of waiting for IRB, we decided to do a couple rounds of convenience testing. This means that we do the testing among just Team Scope. This is not data that we can use for a thesis or for a publication. This is just for the sake of assessing what our starting points would be for the focal distance as well as the frequency of oscillation. So this is a lot of data, but let me walk you through it. The first top tables are for the eye acuity test results, and the bottom 2 are for the survey results. The left side is the first round, and the right side is the second round. So eye acuity works like this. If you get the number 4, it means that you read 4 lines of letters correctly and you missed a letter on the 5th line. For both of our tests, it seems that the control group and the slow frequencies had the greatest positive change, and the faster frequencies had the worst change. Now the survey results are a little messy. There's not really any conclusive results. Now, this is designed to be the most positive post-survey results. So, for example, I had a headache for the first one, control. The control group had the greatest positive change out of all the groups. So, like I said before, this is messy, and we couldn't really conclude anything from these results. We knew that it was very subjective and biased, and at this point we didn't really know how to move forward with our experiment. It is important to note that even though our results were not conclusive, that doesn't mean we failed. In fact, we gained core knowledge that is going to take Team Scope into our current phase. And on that note, John will continue.
Alrighty, can you all hear me fine? Yes, wait. You want me to use my mic? Okay. And can you all hear me? Yeah. Okay. So Scope version 2, or the project we are currently working on, is a sensory computing and object processing entity. So why did we change our project? First and foremost, as Kelsey mentioned, we had inconclusive data. There were a lot of variables outside of our control. There weren't a lot of paths we could take moving forward that we saw in the data, and we really didn't know how to make it that much better to be able to get conclusive results. At that point, we started getting frustrated and hitting a lot of walls, which caused a lack of passion and interest in the project. So we figured we needed, something new to work with. Our mentor was a great support in helping us, choose a new project and in a timely manner. We went through the entire brainstorming process again, started from scratch, had 25 ideas on the blackboard. And then this new project that we have chosen, we believe has a lot of potential. So computers have improved in the last 10, 15 years. It's absolutely amazing the data that we have at our fingertips. We believe that using this data, we can make technology-assisted robots more of a reality. So the applications for this, we believe, are almost endless, without, not excluding personal assistance, domestic assistance, emergency services. So we believe we can do this by incorporating two different technologies: natural language interaction and visual object recognition. So what we want to do is incorporate those two into one assistive machine that will improve assistive robotics. So what is natural language interaction? What is natural interaction? It is the taking of speech to text and then analyzing that text, pretty much how Siri does. So if you ask your phone a question, it can bring up a result. Where is Mount Kilimanjaro? How tall is the Empire State Building? It can analyze what you say and give you a useful result. That's based on several different pieces that I'll dive into a little bit later. Visual object recognition is as straightforward as it sounds. I can hold up an orange and it can tell me it's an orange. I can say, where's Kelsey? And it can find me Kelsey. So we want to be able to incorporate those two different things into one, very helpful item. So we want to do this in a mobile robotic design that involves a camera, motors for wheels, the whole 9 yards as you see there. So natural language, a little bit more in depth, is, you say something, it takes text, and then it goes into semantics, pragmatics, and syntax, which are essentially environmental, context, and vocabulary. So if I say, take me to a bank, you can store money at a bank, but rivers also have a bank. So based on, where you are, what you've said, and other external information, it should be able to tell the difference between what bank you mean. That is kind of our goal in using visual object recognition along with the natural language implementation. We hope to be able to understand a wide vocabulary using context and knowledge to process the phrasing and to obtain more efficient format to be able to identify stuff. So the leading technologies are currently the Nuanced Dragon, which is a speech-to-text commercial application, and then Stanford and UPenn's NLP projects, which are more cloud-based, grammar and syntax engines. So we want to be able to combine those into what I mentioned in the previous slide. Visual object recognition is a fair bit simpler in concept. So, like I said, the oranges, the bananas, that building, that's a TV, that's a cat, stuff like that. That technology already exists. We want to be able to use that technology to be more, assistive, useful in whatever direction we choose. So what we want to do is identify an object, let's say I'm holding up a banana, and have a local database of vocabulary that can identify something that I hold up. But if it doesn't know what that is, if our local database doesn't have that information, we want to be able to access the cloud or the web to be able to create more information to store locally in this database so that it doesn't have to be retrieved from the web again. This is a more efficient system and a hybrid system of local and cloud-based that we believe will be more effective in being assistive. So the visual object implementation comes in two parts. So we've started with IBM Bluemix, which is a cloud-based API for image recognition. And we're also using MATLAB and OpenCV to code our local database. So our short-term goal is to be able to distinguish objects from people. So an orange from me. Perform simple tasks of movement. Like if I say, move forward or move backwards, the robot will do such. Yes, these things already exist, but we want to be able to do this in a local database that we've created ourselves so that we can move forward with our hybrid system. Like the Siri-esque speech to text, and to be able to accurately, analyze context. Long term, to be able to distinguish different objects from each other, like different models of iPhone, and to make conclusions based on, the object recognition and natural language put together. An example application is if Team Scope is in our meeting with our mentor. There's 12 of us in a room, 11 of us in the mentor. The robot, ideally, would be able to come into the room, identify each person in the room, the number of people, the location, and the context in which the meeting is being held. Be able to tell that it is a Team Scope meeting, and be able to offer assistive, sources and feedback based on what we're talking about, discussing, or, etc. So we've broken our team down similar to the last project. We have 4 sub-teams, the natural language coding and object recognition, which will eventually be combined into one once we are able to, join the two. The engineers, which will create the robot itself once we have, enough technology and data to, merit a useful robot. And our external affairs, which takes care of funding, presentations, and constantly updating literature review and methodology. To do what we want to do, obviously, we need to find, understand, and develop the natural language and object recognition software, which is not an easy task, it's very dense. We then want to integrate them for simpler tasks and build the database. That's our primary goal. And then once we do that, we want to be able to control it using nothing but wireless, Bluetooth, stuff like that. We don't want it hooked up to anything, so it can be mobile and assistive. So our present status is we are actually very close to building our first robot. We're actually waiting on a couple of parts, and we have most of the first code to be able to do a move forward, move backward type thing. After that, we'd like to, build a better robot with more funding, a little bit more streamlined, a little bit more high tech, so we can do a couple more things. Along the way, we came across several challenges. One of the main reasons that we changed projects was because we absolutely despised the IRB process. It took a very long time, and no matter what anybody tells you, it's just going to take forever. We had trouble finding a PI. We had a lot of problems, filling out all the forms we needed to fill out to get human subjects for the first round of testing for our old project. So we decided the second time around to go with something that wasn't, human subject testing based, but more coding and computer. The change in direction and topic was hard. We definitely needed to, gain a new understanding of different technologies. We definitely needed to reorient ourselves and figure out how we were going to tackle this new project with much less time than we originally started with. And that comes along with the learning curve of getting in gear and getting all this stuff taken care of quickly so that we can stay on top of things.
So as a conclusion, Team Scope would like to give some advice to the freshmen. The research process is very stressful, but if you're passionate about the project, you'll get through those stressful times. Research is also very rewarding, so when you hit a milestone, it all becomes worth it. Secondly, change is a good thing. Most likely, your team is going to have a shift in the project, or maybe like us, make a complete 180, and you're just going to have to embrace it. Thirdly, team dynamics are also very important and will indirectly impact your future and your success. Lastly, time management and accountability are very important for the success of your team. You need to set hard deadlines and then hold yourself and your teammates accountable for those deadlines as well. In the beginning, we had loose deadlines, and we weren't putting names next to our to-do list, and we weren't getting things done as quickly as we wanted to. But now we're holding ourselves responsible by sending progress and documents to our mentor and putting names next to specific things on our to-do list. And we're more successful in reaching those deadlines. So we do wish you freshmen the best of luck in your future, and thank you.
All right, questions. There was a lot there. Matul.
Hi. First question, what are the data implications of using that local system, and is that a reason why the Canada standard fees are considered to keep it in the cloud?
So the question is, why are we deciding to go local and cloud hybrid as opposed to why Stanford and UPenn decided to go straight cloud?
And what are the data implications?
What are the data implications of that?
Who wants to take it?
So it depends on the software you're using and the breadth. So for example, with natural language interaction, if you're looking at one specific topic, your vocabulary is going to be a lot more limited, opposed to, for example, Siri or other software that's looking at full vocabulary, in which case a local storage system will have no way of managing all of that data. So it definitely has to do with an efficient algorithm, an efficient way of managing your data and storing and looking at exactly how much memory you need for the task that's at hand. And that is something that we will be looking into and seeing how it can interact fluidly with the object recognition in order to alleviate a little bit of that data storage.
At what point in the process did you guys change the direction of your project, and how far do you feel like that set you back, if at all?
We changed projects a month ago. And we changed projects for all the reasons we listed, and originally we thought that was going to set us back a lot. But because we're not doing any kind of human subject or really lab-based testing, we were able to move at our own pace and at a pretty quick pace. We really didn't have any variables we had to rely on early on. It was just a matter of, can we get the code written and can we get this little bot built? And we should be able to do that, easily before the winter break, at least that first initial, local-based system that can do those simple tasks. So we really don't feel that we're that far behind, but we do feel that we have a very long way to go, especially with all the different applications we see this going.
Since this is kind of, especially this technology keeps improving, it's kind of a long-term project that could advance really far. What stage do you guys expect to get to?
So the question was, this is a very long-term project that can advance very far. What stage do we expect ourselves to get to? Artificial intelligence and this type of technology is where most of technology is heading towards in the future. So the possibilities and the directions that it's going in are huge. Obviously, as an undergraduate research team, we are a little limited in what we can do, and also with our knowledge on the topic. We expect to go through a very iterative process. So first, like they were saying, backwards and forwards motion, initial object recognition, then tying it into the natural language technology, and then starting to actually deal with, like I was saying, the data management, the data retrieval, comparing accuracy of what we're using and integrating that object recognition to current existing natural language technologies and seeing how does the time and accuracy compare. So it'll definitely be going backwards and forwards, lots of accuracy tests and so forth.
So in the future, when you finish this project, where do you see this robot helping people?
Hello. So the question was, where do you see this technology in the future in terms of helping people? And